Hey guys, so this is going to be part 2 to the chapter 12 chemistry video. We're going to talk about understanding how the pH scale works and how it affects the hair, skin, and nails. So pH stands for potential hydrogen. So the small p represents the quantity and the capital H represents the hydrogen ion. The term pH represents the quantities of hydrogen ions. In pure water, some of the water molecules naturally ionize into hydrogen ions and some into hydroxide ions. The pH scale measures those ions. Hydrogen ions are acidic and hydroxide ions are alkaline. Only aqueous solutions have pH and non-aqueous solutions don't. So a non-aqueous solution would be like oil and alcohol. Without water, there's no pH. Pure water contains the same number of hydrogen ions as hydroxy ions. Pure water is neutral because it is an equal balance of both acid and alkaline. Now we're going to talk about ions, ionization. An ion is an atom or a molecule that has an electrical charge. Ionization is the separation of an atom or a molecule into a positive and negative ions. An anion is the ion that has the negative charge. The cation is the ion with the positive electrical charge. So the pH scale is a measure of acidity and alkalinity of a substance. It's a scale of 0 to 14. A solution that has a natural pH has a pH of 7, so that's neutral. When a solution indicates a pH below 7, it's an acidic solution. And whenever a pH above 7, that would mean it's an alkaline solution. The pH scale is logarithmic because a change of one whole number represents a 10-fold change in pH. A change of two numbers represents the change of 10 times 10, or a 100-fold change. All acids owe their chemical reactivity to the hydrogen ion. Acids have a pH below 7. Alpha hydroxy acids are derived from plants, mostly fruits. Are examples of acids used in salons to exfoliate the skin and to help adjust the pH of lotion, conditioners, or creams. Thioglycolic acid is a colorless liquid or white crystals with a strong, unpleasant odor that is used in permanent waving solutions to contract and close the hair cuticle. Glycolic acid is an alpha hydroxyl acid used in exfoliation to lower the pH of products. Alkalis owe their chemical relativity to hydroxide ions. Term is interchangeable with base. They have a pH above 7, so that means it's an alkali. They feel slippery and soapy on the skin. An example of an alkali is sodium hydroxide, commonly known as lye, used in chemical hair relaxers, cuticle softeners, and drain cleaners. So the same reaction that naturally ionizes water into hydrogen ions and hydroxide ions also run in reverse. When acids and alkalis are mixed together in equal portions, they neutralize each other to form water. Neutralizing shampoos and normalizing lotions used to neutralize hair relaxers work by creating an acid-alkali neutralization reaction. Liquid soaps are usually slightly acidic and can neutralize alkaline callus softeners, residue left on the skin after rinsing. And now I'm going to talk about how chemistry is going to help you in the salon. So whether you're studying the pH of products, redox reactions, solutions, suspensions, or emulsions, there's a lot to learn about how chemistry affects the products that you use in a salon. Having a basic understanding of chemistry is going to help you with the use of professional products to effectively and safely use them in a salon. So we're gonna do a fun little project. We're gonna pour some water into this clear container, and then we're gonna pour some oil in it, and then we're gonna see what happens. So I'm gonna get my water, I'm gonna pour it in there, okay? And it doesn't matter if it's hot or if it's cold, either is fine. And then we're gonna put the oil in there. I used vegetable oil for this. So we're just going to pour a little bit in there. And just a little bit more, just so you guys can kind of see the full effect. And then we're going to try to mix it together and see what happens. So I'm going to take my spoon and I'm going to swirl it around and see what happens in there. And you can kind of see the bubbles just form, and then the oil just kind of floats around in the water. And then as it kind of stops and it's settling again, the oil floats right back up to the top. So now we're going to take some soap and we're going to put some soap in there. I use Ajax, just soap, Dawn, whatever is fine. So I'm going to pour a little bit in there. And whenever I pour this in here, you can kind of see that the soap floats right beneath the oil. Okay, so we're going to mix this up, and you're going to see that it creates a milky white emulsion. So the chemical nature of the soap allows it to keep the small drops of oil suspended in the water, and this is why soap has a cleaning action. The dirt clings to your skin and clothes because a film of grease holds it in there. The purpose of the soap is to break up the film so that the dirt can be washed away. So in this project, I'm going to pour some water into this container, and then I'm going to get a powdered drink mix, and I'm going to pour it in there. I'm using Crystal Light. I think it's pink lemonade. And then I'm going to mix it together, and we're going to see what happens. So mixing it together, you can see that it forms the pink lemonade. So in this experiment, the ingredient for the solute is going to be the powdered drink, and then the solvent is going to be the water, and then the solution is going to be the pink lemonade. So this experiment, we're going to talk about density and viscosity. So in this cup, I have soy sauce, and I'm going to put some shampoo in it. We're going to see what happens. So as you can see, as I'm putting the shampoo in, the shampoo is floating to the top, and the soy sauce is sinking to the bottom. So density means like kind of how heavy a product or solution is. So in this case scenario, we can tell that the soy sauce is in the bottom. So that means it is more dense than the shampoo. Okay, so you can clearly tell the soy sauce is in the bottom. Okay, and then in this cup, I also have soy sauce. I put the soy sauce first in most of the containers because it was a little messy. So I'm going to pour some oil in here, and then we're going to see what happens. So the oil floats to the top again, the same as in situation 1. And then the soy sauce sinks to the bottom, sorry. So that means the soy sauce is more dense than oil. In this one, I used syrup. You're supposed to use corn syrup, but we didn't have any, so I used regular brown syrup instead. And as you guys are about to see, whenever I used it, both of the products are dark brown, and so it was really hard to see. So I opted out for I tried to put some food coloring in the syrup so we could see if there was a better visual for it, and it was still kind of hard to see. But so here I had the soy sauce in the cup, and then I put some blue food coloring in it to see if it would kind of make a difference. But you can see that the syrup is the one that floats to the bottom, or sinks to the bottom this time. And so that means that the syrup is going to be more dense than soy sauce. So the soy sauce is sitting on top, so it's less dense than syrup. So out of the 3 soy sauce solutions, the only one that the soy sauce is less dense is with syrup. So for this one, we're using shampoo, and we're going to pour oil in it. I already have the shampoo in there. So I'm going to take some vegetable oil, I'm going to pour it right in there. And whenever I pour it in there, you can see the oil floats to the top and the shampoo sinks to the bottom. So in this situation, the shampoo is going to be more dense than the oil. It kind of has a reflection of the shampoo floating on the top, but the oil sinks to the bottom. And in this one, I'm using oil and syrup. I already have the syrup in there. So again, I'm going to take the vegetable oil and I'm going to pour it right in there. And whenever I do that, you can tell the oil floats right up to the top. So the syrup is going to be more dense in this situation. And I'm going to take some syrup and shampoo. I already have the shampoo in there. So then I'm going to take my syrup mixture. I use the blue in there, and I'm going to pour that in there. And you can see that the syrup is more dense than the shampoo. So it sinks to the bottom and the shampoo floats to the top because it's less dense. And I'm going to put just a little bit more shampoo so it's a little bit easier for you guys to see the difference. And see, the shampoo is floating on the top and the syrup is in the bottom. So for the shampoo and the syrup is more dense. The soy sauce and syrup, the syrup also is more dense. And then the soy sauce and shampoo, the soy sauce is more dense. The oil and soy sauce, the soy sauce is more dense. The oil and shampoo, the shampoo is more dense. And then the soy sauce and syrup, the syrup is more dense. And these are not mixing together, so they are considered immiscible. And in this cup, I kind of mixed all of them together with water. So I poured my water in there, and then I'm going to pour some oil in there. So the water is more dense than the oil because the oil floats to the top and then the water stays at the bottom. And then next, I am going to add some soy sauce. So the soy sauce sinks to the bottom, so it's more dense than the water. Some of the soy sauce got stuck in the oil, and so that's why it's kind of just floating there. I'm going to stick some shampoo in there. So the shampoo is more dense than the oil, but the water is more dense than the shampoo, so it's still going to be on the bottom. And then the soy sauce is more dense than the water, so it's all the way at the bottom. And I'm just kind of seeing what it does here. It doesn't mix together, so none of these can mix together.
So this is going to be a fun little experiment on why it's important to wash your hands. So you can see here I have a bowl of water and there is black pepper in it. So the black pepper represents like bacteria and germs. So this is what happens if you touch germs, bacteria. So it's just going to kind of stick to you. Okay? It's just sticking to you. It's there. So now I am going to take one of these and put some soap on it. Now that I have some soap, I'm going to dip it in there. So once I dip it in there, you can see the pepper just kind of spreads away. So you can see there is no pepper on the stick. That means that there was no germs in contact. So that's what soap does. Soap gets away the bacteria and the germs. I also wanted to try this with hand sanitizer. So I dip it in here and you can see germs still get on you whenever you have a hand sanitizer. So that is why it's so important to wash your hands. Hand sanitizer, yes, it does kill germs and bacteria, but you still need to wash your hands. Just because you sanitize does not mean that your hands are clean.